Hello everyone. In this video, I'll explain AWS ECR, that is Elastic Container Register in simple term. We'll see what it is, why we use it, and how it helps with managing containers. So let's get started. So in this video, I'll be covering what is AWS ECR, why we need, and what are the key features and how ECR will work, and we'll see the use cases scenario of ECR. Let's understand what are the benefits and limitations of ECR we have, and I'll also explain you what are the differences of ECR and other container registry. At the last, I'll show you how to demonstrate ECR in AWS account, and also that's a practical session also I'll show you. So let's get started. So what is AWS ECR? So Elastic Container Register is a fully managed container register server provided by AWS. This ECR is similar to the Docker Hub. It's simplify the process of storing, managing, and deploying container images, reducing the complexity of running private container registry. So ECR allow developer to push, store, and pull container image securely and efficiently. It integrates seamlessly with AWS services such as Elastic Container Services, Elastic Kubernetes Services, and AWS Fabric, facilitating smooth container orchestrations and deployment. So, by using this ECR, terms can avoid the overhead of managing their own container registers, and it offers a centralized solution with high availability, scalability, and the security purpose. And it also supports a role based access control using AWS identity and access management, ensuring fine grained permission for image repositories. Furthermore, it offers vulnerability scanning to identify potential security issues in container images and lifecycle policies to automate the cleanup of unused image, ultimately optimizing storage cost and securities. So these feature sets make a ECR a powerful tool for modern DevOps workflow and containerized application deployment. So when it's come to a ECR, by default it is a private container. So let's see why we need ECR. So we already know it's a fully managed container imager register provided by the AWS, and it also plays a critical role in modern DevOps and containerized application workflow. These primary purpose of ECR is to securely store, manage, and share Docker container instead of relying on public container registers like Docker Hub. AWS CR allow teams to maintain private repository, ensuring better control security and reliability. Already we know that it's a primary purpose of the container register. Any one of the container register server, the same use case, that is they are used to store the Docker images, and it also integrates seamlessly with the AWS services like ECS, EKS. So making it easy to deploy containerized application, and it also provide features like image versioning, vulnerability scanning, and fine-grained access control, which enhance the security and the traceability of the container image. By using ECR, organization can optimize their CI/CD pipelines, so reduce dependency on third parties registers and ensure that containerized workloads are stored and managed in a secure AWS native environment. So let's understand the differences of ECR and a Docker Hub. So the difference between ECR, that is Elastic Container Register, and a Docker Hub is, first one, the ECR is managed by AWS and integrated with the AWS services, while Docker Hub is a public repository available to anyone. So ECR is fully managed by AWS, and it is tightly integrated with other AWS services. It is specially designed for users who are operating with the AWS ecosystem For instances, ECR integrates seamlessly with services like Amazon ECS, that is Elastic Container Services, Amazon EKS, and AWS Lambda, which makes deploying containerized application on AWS easy and streamlined. So, why it so matters? If you are using AWS for your cloud infrastructure, ECR provides a simple AWS way to store and retrieve Docker container images. It removes the need for the third party container register, improving security and convenience for user already on AWS. So when it's come to its Docker hub, it's publicly a container repository maintained by Docker, and it's available to anyone and work across various environment, no tied to specific cloud provider. This means you can use Docker Hub on any platform. Docker Hub is default register for Docker users, and it's widely used for both public and a private image storage. And the next difference we have is a primarily for use with AWS services like ECS, EKS, and Lambda. While it's come to a Docker Hub, it's work with any Docker environment. So ECR is built specifically for AWS containerized services. It integrates deeply with the AWS offerings like ECS, EKS, and Lambda for seamless container orchestration and serverless applications deployment. For example, you can directly deploy container from ECR to ECS or EKS. It's automatically handle the image pulling and scaling. So when it's come to its Docker Hub, it's a general purpose registers and work in any environment where Docker is installed. It does not have a native integrations with cloud services, meaning you'll need to manually configure other cloud services, for example, EC2 or a Kubernetes, to pull image from Docker Hub. It can be used in any Docker environment, whether on AWS, Azure, or a local deployment machine. So the third difference we have is a provide private and a secure image storage. Well, it's come to her Docker app can have both public and a private repository. So ECR is designed to provide private and a secure image storage for your Docker container. It also ensures that your container images are stored in a secure environment and can only be accessed by authorized users. So AWS integrate ECR with a its IAM services allow you to define granular access permission based on rules, policies, and a user. So when it's come to a Docker Hub, it supports both public and a private repository. Public repositories are accessible by anyone, and private repositories are only accessible to user with the appropriate credential. While the Docker Hub provides a basic level of security, it does not offers the same level of access control and integration as ECR. So when we see the fourth differences, it's ideal for AWS based containerized application. When it comes to a Docker Hub, it shares Docker images globally. So ECR is specially optimized for users running containerized application on AWS. If you are using ECS or EKS, ECR is the most convenient way to store your container images. It's provide tight integration with these services, streamline deployment pipelines, and automating many tasks like scaling and security. So when it's come to a Docker Hub, it's designed for a more general purpose, making it ideal for sharing Docker images with global communities. Many developers use Docker Hub to upload images for popular open source software, allowing anyone to download and use them. It's widely used in deployment environment to pull pre-built container images for application and services. So when we see the fifth differences, it integrates it with AWS IAM for fine-grained access control. And when it's compared to the Docker Hub, it's a basic control, less secure compared to the ECR. So ECR benefits for AWS IAM, which allow you to define detailed policies for controlling access to your container images. You can assign roles to users and services, granting them specific permissions like read, write, and delete, or certain repositories. These ensure that only authorized users can access sensitive container images. So when it's come to its Docker app, it offers basic access control feature where you can choose whether a repository is in a public or a private. However, it lacks the fine-grained access and control the integration with IAM that ECR offers. Access management on Docker app is a simpler but also less secure when compared to a ECR, especially in a large organization. So when you are using simple you are maintaining your projects like that, you can go with the Docker hub, or like it's public and accessible for everyone. So when you are organization using a private at the time you can go with the ECR. So this is the differences of the ECR and a Docker hub. So the next topic we have is a key features of ECR. So let's understand what are the features we have. So the first thing we have is a secure image store. So ECR ensure that container images are encrypted both at rest and in transit, enhancing the security of the sensitive data and containerized application, and it is a secure way. So integration with CI/CD. It integrates seamlessly with CI/CD tools like Jenkins, AWS Code Pipeline, Code Build. These integration allow for automates build, test, and deployments of the container image. Role-based access control. ECR uses AWS IAM to provide fine-grained permission. It allows control over who can view, push, or pull container image and ensure securing access. Image tagging or versioning. So AWS ECR allow tagging of container images with unique identifiers to track and manage multiple versions of container images efficiently. So, life cycle policies. With life cycle policies, you can automatically remove unused or outdated container images, help to reduce storage cost, and keep the register clean. So, we have a vulnerability scanning. So ECR can scan container image for known security vulnerabilities, allow them to detect and address issue before deploying applications to the production. So these features make AWS ECR a critical component of managing containerized application securely and efficiently within a AWS cloud environment. So the next topic is how the ECR will work. So step 1, image creation and push. So developer create Docker container images on their local system. These images are pushed to the ECR using Docker CLI command, that is Docker push. AWS IAM credentials are used to secure authentication and authorization. Image stored and management. So securely stored container image, the image are encrypted both at rest and in transit, and also support versioning and tagging, enabling developers to track and manage different versions of container image. Image full for deployment. So AWS services like ECS, EKS pull container image from AWS ECR when deploying application. So these services authenticate with ECR to access and pull the required images. Image updates and life cycles management. Developers can update container images as new versions become available. It supports image versioning, tagging, allow easy rollback if needed. Additionally, lifecycle policies automatically delete old unused images, optimizing storage cost and keep the repository clean. So these workflow allow for seamless CI/CD pipeline where container images can created, stored, managed, and deployed in a secure, efficient, and automated way. So the next we have is a use cases scenario for ECR. So the first use case here we have is a CI/CD pipelines. So it stores and manage Docker image for automated deployments. So how it's work? As a part of the CI/CD pipeline, container images are built, tested, and stored in a AWS ECR. AWS Code Build, Jenkins, or other CI/CD tools push the image to the ECR after successfully testing. AWS ECS, EKS, or a AWS Fabric pulls the image from the ECR to deploy it in a production. So, image stacks like version V1.0, V2.0, or latest help managing image versioning. And when it's come to its benefits, it's a faster deployment, version control, and automations. For example, a DevOps team builds a Jenkins pipeline that builds a container image, test it, and push it to a AWS ECR. The ECS services pulls the image from the ECR and deploys it to production automatically. So the next use case we have is a multi-region deployment. It replicates image across AWS region for global availability. How it's work? It supports cross-region replications of container images. Image pushed to a repository in on one AWS region can be automatically replicated to other region. These ensure faster image pulls from the closest AWS region, reducing deployment time. When it's come to its benefits, it's a faster deployment, high availability, and a global search. So, example, a company with the global customer base wants to deploy containerized application in US East 1 and Asian Mumbai region. Instead of manually pushing image to both region, ECR automatically replicates the image from the US East 1 repository to the Mumbai repository. So the next we have is a application modernization. So it's migrate application into containerized workloads. How it's work? So applications are containerized using Docker and stored in a AWS ECR. So these containerization applications can be pulled by AWS ECS, EKS, or AWS Fabric for modernized deployment. So the container images are versioned and updates to apps are made by pushing a new version to ECR. So when it's come to its benefits, it's a modernization, version controlling, and a portability. For example, a company has a application that runs on an on-premises service. They containerize the application using Docker and push container image to AWS ECR. Then they use AWS ECS to deploy the managed container applications, gaining the benefits of scalability, fault tolerance, and automated deployment. So the next we have is a security and compliance. So use vulnerability scanning to ensure secure deployments. How it's work? When images are pushed to AWS ECR, vulnerability scans are triggered automatically or manually. ECR scans for common vulnerabilities and exposes its libraries, frameworks, and dependencies within the containerized images, and reports are generated with the critical, high, medium, and a low severity vulnerabilities. Teams can patch issues and push updated images back to ECR. So when it's come to its benefits, is a security, early detection, and a risk management. So for example, a DevOps team pushes a new container image to ECR. It scans the image and detects a vulnerability in a open SSL. The team is alerted and patches the image by updating OpenSSL to secure version. The updated image is the repushed to ECR, ensuring that no vulnerable images is deployed to production. So this is the use cases of the ECR. So the next concept we have is the benefits of AWS ECR. So the first benefits it is secure and are encrypted. Images are encrypted at rest using AWS Key Management Services, that is KMS. Images are encrypted in transit with HTTPS to ensure secure transfer. It integrated with IAM provides channel control over who can access and manage images. So integrated with AWS services. It seamlessly integrated with the ECS, that is Elastic Container Services for container deployment, and it also supports EKS, that is Elastic Kubernetes Services for Kubernetes based container application, and it also works with AWS Fabric for serverless container deployment, and it also support integration with the CI/CD tools like AWS Code Pipeline and Jenkins. And the next benefits we have is a high availability. Built on AWS fault tolerant infrastructure, ensuring minimal downtime, and it also supports cross region replication, making image available across multiple regions. So it's also ensure global accessibility to container images, improve deployment speed and reliability. Cost effective. Pay only for storage used with no upfront fees. So lifecycle policies automatically clean up old or unused image, reducing storage costs. No additional charges for data transfers when pulling image from the same region. So the next we have is a operational simplicity. It's a fully managed service, removing the need for manual setup patch upping and scaling. Automatic image scaling detects vulnerabilities in a container images, and it also reduces maintenance overhead, allow developers to focus on application deployment instead of infrastructure management. So these are the benefits of ECR. So let's understand what are the limitations we have. We have storage cost. While AWS ECR is a cost effective in terms of storage, the cost can increase significantly if a large number of container images are stored without proper lifecycle management. User must configure lifecycle policies to avoid the accumulating unused or outdated images that can lead to higher cost. So limited regional access. In this, we have a limited region. Its replicate supported is not automatic and it needs to be manual configured without replicating. Accessing container images in regions outside the ones where they are stored may incur higher data transfer cost and result in a lower access. So no built-in image sign. ECR does not natively support signing images to verify their authenticity. User need to implement external tools such as notary or third party solutions for image signing, which adds complexity to workflow. So limited image tagging features. So ECR allow image tagging. It lacks advanced features like multi-tagging, assigning multiple tags to single image, or tag immutability, preventing tags from being overwritten. So these features are available in other container registers and may be required in certain use cases for being image management. So vulnerability scanning limitations. The vulnerability scanning features in ECR scans image only for known vulnerabilities from a limited set of sources. For example, Amazon Inspector. While it helps detect some security risk, it may not identify all vulnerability, especially for highly customized or nice based images. So no multiple account image sharing. Sharing images between AWS account is possible but requires manual configuration via repository policies. Unlike some other container register, it does not have a straightforward features for multi-account images sharing that can easily enabled. So these are the limitations of AWS Elastic Container Register. So we have ECR versus other container registers. So let's understand these things. So the first feature here we have a integration. So when it's come to a AWS ECR, it's integrate natively with AWS services like ECS, EKS, and Fabric, making it ideal for application hosted within a AWS ecosystem. When it's come to a Docker, it has a limited integration outside of Docker own ecosystem but can work with various CI/CD tools and third-party services. So when it's come to Azure Container Register, it's integrated seamlessly with Azure Kubernetes services and other Azure services, offering a strong ecosystem for Azure based deployment. So the next feature here we have is a security. AWS ECR offers robust security features including IAM based access control, image scanning for vulnerabilities, and encrypted storage. both in transit at the rest. So Docker Hub provides basic security with the option for both public and a private repositories, but lacks fine-grained access control like ECR or a ACR. Azure Container Register uses Azure ID for user authentication and provides private repository for added security along with vulnerability scanning for images. Cost. AWS ECR follows a pay as you go model based on the amount of storage and a data transfer used. So Docker Hub offers a free tier with limited features and a paid options based on usage with additional features available in the premium plans. So Azure Container Register also uses usage based pricing and offers additional capabilities in AI trials, which includes features like geo-replication and enhanced securities. So last we have a features called private repositories. So AWS ECR and Azure Container Registers both supports a private repositories without a restrictions. Docker Hub also offers private repositories, but the free tier has limitations on the number of private repositories. So in this summary, the choice between these container registers dependent on the cloud platform using AWS, Azure, or a Docker, the securities and the integration features you need, and you can cost preference. Your cost preference. AWS ECR and Azure ACR offers comprehensive features for users deeply embedded within their respective cloud ecosystem, while Docker Hub remains a more universal solution for containerized application with a broader but more limited features of set. So this is what all about the uh, Elastic Container Registry. So let's go to the AWS account. I'll show you how to create a repository, how to build and tag and push through the AWS command line. I will show you the practical session. So let's go to the AWS account. So let's get start with the practical session. So go to the ECR. So, the Amazon Elastic Container Registry shares and deploy container software, public or a private. Amazon Elastic Container Registers is a fully managed container registry that makes it easy to store, manage, share, and deploy or containerize missions, artifacts. So, by default, the Elastic Container Registry is in a private only. So, let's create a repository. Click on Create. So, here give the repository name. So I'm giving the demo repository. So then here we have a image tag mutable. So this means the mutable settings to use when tag immutable is turned on repository tags are prevented being overwriting. So for that purpose here, so when you are giving mutable, the image tags can be overwritten. So if you are giving immutable, it prevented by being by overwritten. So I'm giving the immutable. So in the encryption should be in a default. So in image scanning and setup, so we should enable the scan and push to have each image automatically scan after being pushed to a repository. After being pushed the content to the repository, it will scan and push directly. If it enable, each image scan must manually. We should manually scan. For that purpose, before only I'll be enabling. So click on create. So this will create a repository for us. So see here we have, so the repository has been created. So if you go to the view push command, so here only they have given some command. So use the following steps to authenticate and push an image to your repository for additional result authentication methods including. So retrieve an authentication token and authentication your Docker client to a registry, use the AWS CLI. So here we need to use a AWS CLI. So firstly we need to install AWS CLI to our system. So for that what you need to do is, so install AWS CLI. So first one, installing or updating latest version of the AWS CLI. So in this, scroll down. So here we have Linux, Mac OS or a Windows in the Linux part. So scroll down. So here Snap package. Go to Snap package and follow these steps to install the things. So I have already installed those things. So let's check for the version of AWS CLI. So it has been installed and it's showing an version. So what is AWS CLI? So Amazon Web Service command line interface, it is a tool that allow you to manage and interact with the AWS services using the command line commands. So it also provide a unified interface to AWS, enable user to automate tasks, managing resources and perform operations without using the AWS management console. So that's why we use the AWS CLI. So let's run the command AWS configure. So this command is used to set up the AWS command line interface with your AWS credential and default configuration. So it allow you to provide information such as your access key, secret key, default region and the output format. So let's click on enter. So it will ask for the access key and a secret key. So for this purpose what we need to do is, we need to go to AWS account and we need to create a user for it. Let's go and create a user and let's get the access key and a secret key for the purpose. So go to the IAM. Sorry. So here let's click on create user. So click on user. So here I'm creating for the demo purpose, right? So I'm giving the demo and I want to create so custom password. So user it. So uncheck. So click on next. So as of now, I'm not attaching any policies for this. I need to take the access key and a secret key. So that's why I'm showing you. So click on next. So create user. So see, um, for you want username and a console password, so download your CSV file. So now what we need to do is view user. So here in the security credential we can see the access key and a secret key. Create a access key. So here I'm using command line interface. So I understand, acknowledge. So click on next. So click on create access key. So this will create access key and a secret key for us. So this we need to paste it in the access key part and a secret key part. So let's copy this and you can also download the CSV file also. So I copy this. So let's go and paste in VS Code. So copy the access key and it also asks for the secret key. Copy that also. So here it's asking for the default region, so my default region is EU North 1, and default output format is, click on enter. So, the AWS access key ID used to identify your AWS account, secret key used to authenticate your identity, keep it secret and safely. So, default region, the AWS region you want to work with, like I have given you one, not like that, etc. So, default output format, these format for AWS CLI command output, and the default it is in a JSON format. So, this is the command. So let's go to the ECR that we have created the repository, right? There I'll show you some commands. We have created the repository, right? So go to view push command. So here they have given some steps to follow for us. So the first step, retrieve an authentication token and authenticate your Docker client to a register using the AWS CLI. So copy this command and paste it in the VS code. So paste that command. So here AWS ECR get hyphen login hyphen password hyphen region U North 1. So these command retrieve a short live authentication token password for ECR, that is Elastic Container Register hyphen region EU North 1, specify the AWS region where the ECR hosted. The token is valid for 12 hours by default. So the pipe passes the output password from AWS ECR get login password command to the next command, that is Docker login hyphen username AWS hyphen password hyphen stdin and the account number .dkr.ecr.er north 1 amazon.com. So username AWS, it's used to username login with in the ECR. The password STN reads the password from the input provided by the previous AWS ECR get login password command, and the account ID, this is the URL of your ECR repository, and hyphen password STN reads the password from the input provided by the previous AWS ECR get login password command, and the ID, this is the yes. So why it is necessary? It needs to authenticate with AWS ECR before you can push or pull Docker image from your private container register. AWS uses token instead of permanent password for security reason. So when to use it? Before pushing Docker image to the ECR. So before pulling Docker image from ECR. So when you click on enter, it will show. Sorry, it will. So yes, it will show an error. Why? Because we need to give the permission. So that is fully access permission, ECR permissions in the IAM. So that's why it's showing an error. So let's go and give the permission in the IAM that we have created the user IAM, right? So at there we need to give the permission for this operation. So for individually I'll give the individually giving the access for particular one. Instead of giving individual, I'll give full access in the IAM. So let's go and IAM and give the. So when you get entered to the demo, so here add permissions. So add permissions. So attach policies directly. So here search for ECR. So so in the VS code, we get the access token, give the permission for this. So next thing, So here it's not showing the full access. So it's not showing the full access. So let's give one by one access only. So I have given now. So there it's showing they need a get authentication token. For that purpose, I have given these permissions. So click on next. So it will give the permission for us. So I have given the access for the get authorization token. So let's run the command again. So as the login has been succeeded, so let's go and run the second step. What have they given? So the next command we have is a docker build -t demo repo dot. So the docker build command tells Docker to build an image. It look for a file named Docker file in the specified directory. In this case, the current directory dot. -t demo dot repo. -t tag allow you to give the image a name and a operational version. So demo repo is the name or tag of the Docker image you are building. You can also specify versions like demo repo hyphen v1. So dot, this is the build content. It tell Docker to look as the current directory for the Docker file and the other necessary file for the Docker build. If the Docker file is in different directory, you would specify that the path instead of dot. So let's run. So before this, I'll show you one thing. So I have created a Docker file. So in the Docker file, I have written that from Ubuntu latest. So it pulls the latest Ubuntu image from the app. This image acts as the starting point for building your custom image. So this is the content I have written in the Docker file. So before running the build command, you need to create a Docker file. After that, you need to run the build command. So let's exit from this. So what happens when you run the command docker read the Docker file? It copies the file specified in the Docker file. It install dependencies and set up the environment inside the image. Finally, it saves and resulting as image depot repo in your local Docker image, so repository. So the next command that we have is a docker tag. So this command creates a new label for an existing Docker image. It does not create a new image. It just appoints to an existing one with the new name. And the demo repo latest, this is the name of the local image that you're already built in using the Docker build -t demo repo dot command. This latest tag is the default if no tag is provided. So and the id amazon.depot latest. So this is the fully qualified path of the image in AWS CRI, and the 825, it's the account id. DKR ECR North 1 is the endpoint. So demo repo is the name of the ECR repository where you want to push the image, and the latest is the image tag. So why do we tag image? To push Docker image to a cloud-based register like AWS ECR, Docker needs to know where to send the image. Since the local images is called demo repo latest, you have to tag it with the AWS ECR URL. So Docker know where it to push. Without this tag, Docker would not know which remote location is to associate with your local image. So click on enter, it will tag. So the next command we have is we need to push this things on. So these Docker push command uploads the docker images to our container register, and this is a fully part of the docker image. So the account id and endpoint of the url and the name and the tag of the using the pushing. So what happens when you push the image? Docker image sends the image layers to aws ecr. If the image layers already existing in the ecr, they will be skipped. Docker uploads only new or changed layer. When the image push in a complete, it becomes available in the AWS ECR console. So let's enter this. So see, it's showing an error because it is not authorized to perform initiated layer upload. So in the IAM, we need to give the access for the initiate layer upload. So let's go to the IAM and give the access to the initiated layer upload. So in this user, we need to give the permission for that identity, right? So attach policies directly. So here I'm giving full access. Before we have a search for the full access, we did not find. Now I'm getting that one. So I'm selecting this and giving full access permission for this. So add permissions. So it will create a policy for us. So let's go and run that command again. So let's see what will happen. So let's run that command again, docker push. So it's now it is pushing because we have given a fully access, right? So that's why it's pushing. So let's after pushing, yeah, it has been pushed. So now we need to go and check whether the image has been pushed or not. So let's go and check in AWS account. So as the image has been pushed to the repository that what we have created earlier. So the latest image tag has been pushed. So this is how the ECR will work. So that's all about the practical session. So yes, that's all about the AWS Elastic Container Register. I have covered every topic and I'll explain how the things will work, and also I have shown the practical session on the ECR also. So thank you.